Yeah, good day, folks. This is a Form 2 series on equations that involve manipulation of fractions. And in this series, I think what was important is to understand the mathematics behind reciprocal, which is a term that we use to define opposite of a given fraction. So I'll start by jotting a bit of examples on how we play around with the reciprocal. Then we'll see how best it can assist in our explanation of solutions to these given problems. All right. So I mentioned the term reciprocal, which we said is just opposite of a fraction. So if I have a fraction like 1 over 4, then I'm saying the reciprocal becomes 4 over 1. So if I have a fraction like 5 is a whole number, but as a fraction, we'll make it 5 over 1. So we are saying, using the same sense, the reciprocal of 5 becomes 1 over 5. Why do we need this? Because if we bring the product here, the result is always a 1. So to eliminate a fraction, we need its reciprocal, and the product will give us a 1. So if we have that in our minds, then dealing with equations involving fractions becomes, and to solve equations involving fractions, that's our intention or objective. Now I want to solve equations also involving word problems that will turn into fractions. We'll see what we'll get. Then the third one, solve equations fractions in the denominator. So we need the reciprocal to get rid of the denominator part. Apply methods to real life structured test questions, and we'll see how it works. So let me take you through a number of questions that I have, and we see how we apply the opposite of the fraction to find the unknown. So with this problem, we're interested in finding the value of x. So we will rewrite the fraction as x over 6b equal to 5. So the opposite of this fraction, which imaginarily we can see that is 1 over 6 multiplied by x. So the opposite is going to be 6 over 1. We know 6 over 1 gives us 1. When 6 and the numerator and denominator alike, they cancel and give us a 1. So we remain with x being equal to 6 times 5, that's 30. Moving to the second problem, where I have a fraction which is clear, that's 2/3 of x being equal to 10. So the reciprocal becomes 3 over 2, but I'll multiply both sides because of the equal sign. Once I have reciprocal fractions multiplying each other, they simplify to a 1. But there, I know 2 divided 2 is 1. 2 into 5 into 10, that's 5. 5 times 3, 15. So what it implies is x there is actually 15. Then on the third problem, you can see that there's a fraction again. And when this happens, we assume there are brackets and the fraction is 1 over 5. So having that in mind, it means the reciprocal is 5 over 1, which is actually 5. And we'll multiply both sides as x minus 4 over 5 equal to 3 multiplied by 5 again. When we have 5 on numerator and denominator, they cancel, giving us a 1. Therefore, x minus 4 equal to 3 times 5, which is 15. And as I proceed with my calculations, what it implies is if I transpose, because I'm looking for x, then end up having 5 plus 4, because when we transpose, the sign changes. Therefore, our x is actually 19. Then moving to the fourth one, I've got 7 over x, and for 7 over x, if I want to get rid of the fractional parts, which is actually 1 over x, it means I'll multiply both sides by x. Then when it's like that, x and x, they'll cancel, remain with 7. So 7 is what 1 times x, which is actually x. But the proper notation is to start with x unknown equal to 7, because we can reflect the equal sign. Then number 5, I have a fraction there, like we did with the previous exam. We're saying this will be treated as a unit for the numerator, where our fraction there is 1 over 4. So the reciprocal becomes 4 into x plus 2 all over 4, but we multiply both sides by 4 because it wasn't there. So when numerator denominator are the same, they cancel. X plus 2 to give us 6 times 4, that's 24. So finally, when I transpose 2, I'll end up having 24 minus 2, which will give me 22. Moving to, I think it's now more of word problems. 1/4 of a number. So if we say a number, it means it's x. So 1/4 is actually we're dividing by 4 is 8. So we want to find the x. So we can see clearly that the fraction is a quarter. So I'll multiply by the reciprocal, which is actually 4. And it will multiply both sides, we end up having x being equal to 8 and so, which is actually 32. Then I'm moving to the next problem, a bit complex, because what we'll do here, we don't start by the reciprocal. I want to start by transposing 5. So we end up having x over 3 being equal to 12 minus 5. But we know x over 3 it will be in simpler terms as well as 7. So the fraction is a third, so the reciprocal becomes 3 over 1, so you multiply by 3. The 8 cancels, so my x is actually 21. Then I'm moving to number 8. So 8 there, my denominator is a unit as x plus 2. So the reciprocal becomes actually x plus 2 because what we want is to get rid of the fractional part. So I have x plus 2 multiplied by 10 over x plus 2. But we'll multiply both sides even here times x plus 2. Then here to cancel. I remain with 10. So 5 times x, that's 5x. 5 times 2, that's actually 10. So I have 0 equal to 5x. When I transpose this 10, because it will be 10 minus 10. And when I divide both sides, I wasn't saying 0 equal to 5x. So if I divide here by 5, here by 5, it cancels. Therefore, my x is actually 0. Then moving to the next word problem again, a number decreased by half of itself. So that number we don't know it. We are decreasing it by half of itself. So it's half x. It gives us 20. And what we know is this number, I mean, it actually gives us half x in essence being equal to 20 because it's x minus half. So I want to get rid of the fraction. So I'll multiply both sides by 2, cancels. My x is actually 20 times 2, it gives me a 40. And finally, I have fractions both sides. When I have fractions both sides, I don't know, we were supposed to use a method called cross multiplication, where diagonally these things they multiply, and even these ones here they also multiply, but the result will come with an equal sign. So if I say x times 1, that's x. When I say 3 times 2, that's 6. So my x is actually 6. And that's a new method that we used. It's called cross multiplication, and it works when we have got fractions either side. That's where we use this method. So it's only applicable where both the left and right hand side of the equation has got fractions. Thank you.